Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT from weatherist.com, the Colonel of Confusion, the Captain of Chaos, the Commander of Catastrophe. It's Saturday, midday, November 1st. Let's talk weather. A lot to talk about here. We'll talk about the November 1st coastal low, the model performance, the next 2 weeks, some changes in the sea surface temperatures regarding and the El Nino, whether it's actually showed up or not, and finally the Siberian snow covering the QBO. So let's get right to it. This is the surface map here. We have two lows. Originally, when the model started showing this 7 days ago, it looked like there was going to be one big low here, more typically off the coast in this area. Let me get my marker out here, right off of here. And, of course, that would produce the snow in West Virginia, Maryland, and Pennsylvania. But that turned out not to be the correct. As we know, the main low is developed down in here, which is very unusual for late October, early November, for the low to drop that far south. But that's why northern west South Carolina and the western mountains of North Carolina got crushed with the snow. We can see that here with some very nice snow amounts. Let me enlarge this here a little bit. And you can see again. And in the mountains of North Carolina, along the Tennessee border there, Mount Mitchell and other places, I think Mount LeConte, they've had 22 inches of snow here, as you can see, 18 inches of snow. Very impressive, above 5,000 feet. Hard to forecast exactly how much snow is going to fall. I went for 8 inches or more. Only reason I went that low was because it was November 1st. I mean, this is just almost a black swan event for the mountain areas. It's pretty extreme. Now, this is the European model from a couple days ago, actually a week ago. And the European, as you can see, October 25th. And the European, as you can see, has the upper low, let me call my marker, right here over West Virginia. And actually, it's down here. So even the European didn't get it quite correct, but it was closer than anything else. Now, I saw some comments today, actually a tweet from Jim Cantori arguing that the GFS actually did better job performing than the European. Of course, as you'll see, that's absolutely ludicrous. That did not happen at all. I'm not sure why folks get this idea in their head, but they do. So let's take a look at it. Here's the European from 7 days ago, again, a week ago. And notice what's important here is that the European does correctly show that the really cold temperatures are over the mountains of North Carolina and southwest Virginia. And that's where the best snow was. And you can see the low here east of Norfolk. And that was wrong. The low was actually down here, but it was pretty close for 7 days out. This is the GFS. I mean, this isn't even close. Compare that to that. Really? You think the GFS is better than the European? Okay, whatever. And you can see that below is over here. Now, that's not a bad solution given the fact that it's late October, early November. Typically, that's what's going to happen. But the model was wrong. I mean, there's no way to describe it. You're wrong. And this is the European from 6 days out. And you can see, again, it had the big low east of the Delmarva moving off the Cape Cod coast. And again, this seems to imply, this is a pretty typical scenario, that you would get good mountain snows from central New England down to southeastern New York, the Catskills, the Poconos, Pennsylvania, into central and western Maryland, maybe West Virginia. That's what that would imply. But in fact, the low ended up being down here. So all the snow is down here. Bada boom, bada bing. Not that complicated. And now this is the GFS from the same time frame. Compare that to that. That to that. Really? Okay, GFS, good. And you can see the GFS had no clue. And this is 24 hours later on the 26th. Still no clue. Finally, the GFS got a clue, as you can see here. Let me advance it. The GFS had a clue here on the 27th, which is only 5 days out. So it has a significant low there. It's not that close to where it should be, but it's pretty close. It's showing a very powerful system. So you give it the model credit there. It has the big cold hold high coming down. Very impressive system. So the GFS did okay. It just didn't do good as the European. This is the Canadian, which was wretched. This is the Canadian, again, from October 26th. No clue. Has a low somewhere off the coast on the 27th or 28th. This is only 3 days out, 4 days out. Really not a clue at all. Now here's the GFS getting a clue. This is as of 96 hours out, so this is, I guess, this is the 27th, and the GFS didn't really pick up on something. It picked up on here's the upper low coming down this way. There's the main low, and then the developing here, as you can see it, and then finally the big low here. And you can see it's got nice heavy snow in this whole area, and that's pretty close to what happened. That's not a bad solution. That's not a bad model depiction at all. Let's talk about the next 2 weeks here. Now, I'm presenting this map from October 30th to show something in particular. There's been some talk about the northern Pacific water temperatures where the PDO is, the positive PDO, dropping off, cooling, and how that might affect the PDO and turn it neutral or maybe even negative during the winter, and that's going to disrupt everybody's winter forecast. Let's take a look at that carefully. Now, over the past several weeks, there's been a lot of big weather systems which have hit the British Columbia Pacific Northwest coast. And one of the and this map here from October 30th, this is the jet stream map, shows why that's happening. Okay, this feature here is causing surface low pressure to advance across the Pacific and slam into the Pacific Northwest like this. And of course, you're getting upwelling, west to southwest winds, and that causes upwelling. So the sea surface temperatures are dropping. So that's what that's what's been going on, which is why we've seen that drop. And we can take a look at it. This is the drop over the last 30 days. And you can see very clearly here that the water temperatures in this part of the Pacific Ocean have cooled off significantly. I mean, that's 2-3 degrees below normal, maybe 2 or 3 degrees dropping over the last 30 days. This is the last 30 days in here. But notice in here, the waters have not dropped at all. They stayed pretty close to neutral. And if we look at the actual temperatures themselves, excuse me, we skipped this, there we go. And then we can see the water remains quite warm here off the coast of North America and Canada, the United States. But again, it's quite cold still. It's dropped off here. Again, you can see it very nicely. Temperatures actually below normal in North Pacific. Now the question is that going to continue? And I don't think it's going to. Now, let's take a look why. Now this is the GFS a week from today, November 7th. And it has a nice system here, nice trough, as you can see, very nice right here. Actually an upper low over New York State. And then the trough itself right here. That may even be a interior New York State, northern New England snow event, and the Great Lakes. But what's happening here is this. See this feature here? This is a block. This is a negative EPO developing, potentially. And if the EPO develops in here, and these connect up like this, you'll get a much bigger ridge, and then it will turn really cold. Now, that doesn't look like it's going to happen anytime soon, but something to watch out for. But more importantly, what it does is this feature gets driven backwards because this feature is developing. And we'll see that here in a second on the models. Now, this is November 2009. Now, the reason I'm showing this particular map is because a lot of people may be concerned that if we have some warm days in November, and we will, that somehow it means something. It doesn't. This was right before one of the great winters of all time, a few years ago, 2009, 2010, with huge snowstorms and blizzards up and down the east coast of the Midwest. November 2009 was warm and wet, and it was quite warm. So, again, no reason to think that November means something. It doesn't. All right. Now, this is the GFS high resolution. This is the new one, the T1534. The resolution here is down to 13 kilometers. This is experimental, and it goes live in December, I believe, according to the folks at NCEP. And what's happening here, we can see some nice features. First, there's our block here developing over here. There's our vortex developing, the polar vortex where it should be. We're getting a bit of a trough here. And then this whole system is beginning to change out here in the Pacific. This is shifting back to the west. So that's at 240 hours out, November 7th. Now, this is the GFS ensemble, and you can see with a bit more clarity here, this is now back in here. This was over here. That's going backwards. And that's allowing ridging to developing here. But more importantly, it's going to stop the upwelling in the North Pacific. So the cooling of the sea surface temperatures there will stop, and it'll begin to warm over time once again. So that's why I'm not particularly worried about the cooling of the sea surface temperatures in the middle portions of the northern Pacific Ocean. Now, this is the European, which is even more impressive. Now, look at this up here. This is a nice EPO developing up in here. And you can see, and again, this system which was here is now, look where it is, back here, moving towards the Aleutian Islands. So we're getting a nice ridge developing here and some cold flow. Not a really cold pattern, nothing to write home to mom about, but definitely a shift in the pattern by the time we get to mid-November. This is the GFS ensemble at 330 hours out, with November 14th, showing the same sort of thing. And this is the CFS here for 11 to 15 day. And again, we can see the EPO right here, and there's that vortex shifted all the way back to Aleutian Islands, the Aleutian Low, which is allowing a ridge to develop, some sort of ridge here on the west coast a little bit. And more importantly, it causes the upwelling here to stop. So, and again, this is a seasonally cold pattern. It's nothing very impressive per se. If we look at the large scale features, we can see some interesting things here. The Scandinavian block is beginning to push towards the Arctic region a little bit. That's interesting. Excuse me. We can still see our Aleutian lows here developing in the Bering Sea very nicely. So this is a nice map. It gives us large scale perspective of what's going on in 11 to 15 day. If we look at our temperatures on the GFS ensemble, eastern half of the country looks seasonally cold, warm on the west coast and the Rockies. And now week 5, week 4 or 5, we go into days 21 to 25. The CFS actually loses the pattern a little bit here. I don't think this is correct, but it does. So we'll see if that happens or not. I'm not convinced one way or the other. Now let's take a look at some final winter indicators here. First, here's the El Nino. As you can see it, this is from the Australian site, so you can see all the numbers here very clearly. You can see that temperatures on ENSO 4 almost 8/10, 9/10 of a degree above normal. ENSO 3 and 4. ENSO 3 went up again. ENSO 2 held steady. ENSO 1. So I think we are now in an El Nino, a weak one. It's not official yet, but you can track this stuff on the Australian El Nino site, and they're doing a pretty good job with it. And if you look at the El Ninos, during El Nino, Al Marinaro came up with this, Al Joseph. This is something he developed, that when you have a, let me call it my marker here so you can see it, negative, when you have an El Nino, I should say, when you have El Nino, you can use this chart in October to look at sea level pressures in the northern Pacific Ocean, in the North Pacific Ocean. Okay, and his figure comes up with 1010.8. And if you look at where that place is 1010.8 in a negative NAO. Now, once your pressures go above a certain level, above 1,013, then you start getting a signal for a positive NAO during the winter months. But the value is 1010.8, which is well below 1013, so it's a pretty good sign of a moderately strong negative NAO developing for the winter months. Another scale he developed is looking at the upper level winds in May, September. And this is useful, again, here, May and September. And again, this is for the December, January, February North Atlantic Oscillation. See it? And what his figures came out with is, when he ran his model here, came out with 0.13, which is a minor to moderate NAO for the winter months. So this usually works out pretty well. Almost every year he's gotten it right. There's been 2 years since 1980 where his model's not worked. So it's a pretty good model, and it really works. So we'll see if that actually verifies. Now this is the SAI, the Snow Advance Index. It's now over. It's the October's over, and we can see that at the end of the week 42, it exceeded the October 2009 buildup of snow, and only the one in October 1976 has exceeded this one. And that, of course, we saw the historically severe, brutal winter of 76-77. This is the one from Canada. It's the same sort of chart, and if you look at the actual Snow Advance Index, it was charted here, and you can see the blue line. That's what we're looking at here. Let me call it my marker. The blue line, okay, that's what we're looking at here. And you can see the blue line, that is the current year as of 2014. See it right there? So as you can see, way higher than anything else on the chart, way higher. If we look at the final number, we'll notice there's a little bit of a drop-off right here at the end. As you can see it, a little bit of drop-off right there. But that's not what's important. The thing here is the slope of the line, and that exceeds anything else. So that's what's important, not so much the actual minor perturbations of the line itself. Okay. So that continues to show a strongly negative Arctic oscillation for the winter months. Now this is the QBO here. Let's talk about this for 1 second. This is the quasi-biennial oscillation, the high-level winds at 30 millibars, the very, very top of the atmosphere over the equator. And the reason why this is important is because what this thing does is it helps indicate whether it's going to have a negative Arctic oscillation or a positive Arctic oscillation, more blocking or less blocking. So what we're looking at here is in October. Here's the October value. You can see it right here. Okay, see how it's touching the dark green in October? If you look at that scale, that's around -20, -22, and that's what the value was. But now we're headed for November. And as you can see, the dark green has disappeared. And instead, we're looking at the light green. See that right here in November. And that's around -10 to -20. That means that the QBO is weakening. It's coming up towards zero. Now, why is that important? Who cares if the QBO is coming up? The reason why it's important is because, this is an enlargement. You can see it even better. November 1st, light green, -10 to -20. But the reason why this is important is because this table shows that when the QBO is rising and it reaches -10, -5, as you can see right in here, these areas in here, you have a 75% chance of seeing a negative NAO during those months. A lot of blocking patterns. Okay, as it's coming up. Okay, and once, of course, if it stays very low, if it drops negative, then you have a very high chance of seeing a positive NAO. And if it goes way up to the positive values, you also have a high chance of seeing a positive NAO. But right now it's rising, and that's a good sign going into the winter for winter snow lovers and cold lovers, because it seems to indicate a negative NAO developing. This is meteorologist DT from weatherist.com. I'll talk to you soon.